Hi, ma'am. Can you hear me?
Good morning, ma'am. Are we audible, ma'am?
Yes, ma'am.
Yeah, thank you. Thank you, ma'am.
Sorry for the delay. Actually, I was waiting on another meet, and just now I spoke to Padmasai ma'am, and she shared the link.
Sorry, ma'am, for the inconvenience. We just, I take this privilege to introduce today's chief guest, Sireesha Jasthi garu. She is working as an assistant consultant in Tata Consultancy Services. Ma'am has completed her Bachelor of Technology degree in Computer Science Engineering from Andhra University. She has done her Masters of Technology in Computer Software Engineering from JNTU Hyderabad College of Engineering, Hyderabad. She is right now pursuing her Doctor of Philosophy from Data Science and Machine Learning from Geetham Deemed University. Ma'am was associated and she worked as an assistant professor from our institute, which is VNR VJIT Hyderabad, in the Department of CSC. She was associate professor for Ballareddy Engineering College, Hyderabad, and associate professor in DRT College of Engineering and Technology. I welcome you, ma'am, on behalf of IEEE SPS event. And today, ma'am will be addressing for the session of Introduction to Machine Learning. Thank you, ma'am. The session is over.
Thank you, ma'am. Thank you, Manish. Please let me know. Can you see my screen, ma'am?
Not yet, ma'am. Can you please share it?
Yeah, let me check.
Yes, ma'am.
Good morning, Vananda. Yes, ma'am. Shall I? Am I audible, ma'am?
Yeah, you're audible, ma'am. It would be great if you can switch on your cam, ma'am, because audience.
Yeah, sure.
Perfect. Thank you.
Yeah. Hi, everyone. Let me share my screen, my PPT. As part of this introduction to machine learning, I'm going to discuss about all this AI versus artificial intelligence versus machine learning versus deep learning, and what are the different types of data analyst versus data scientist and data engineer. What are all the different types of data we encounter when we are working with data, that like CSV files or unstructured data? And next one is what are all different machine learning algorithms? And I just wanted to explain with one example how the machine learning process takes place. For that, I have taken that linear regression. If you see if you see this diagram, we can easily understand that deep learning is the subset of machine learning, and machine learning is the subset of artificial intelligence. When you come to this artificial intelligence definition, you can see simply we can say we are enabling the computers to mimic human behavior, or we can say it is a branch of computer science which is dealing with the simulation of what is that our intelligence behavior in computers. Uh, so that is nothing but simply we can say we are making the however in whatever way we are what is that performing the task with your human intelligence. Similarly, we are making this to work like that. And next one is machine learning. This machine learning is there in the artificial intelligence. In order to make that, we are writing some, we are hard coding the what is that application, and we are doing that without any explicit programming. We are trying to uh, predict something, or we are trying to what is that whatever task artificial intelligence is doing, here also we are doing the same thing in machine learning without explicitly writing the code. And when you hear the word deep learning, immediately one thing will come into the picture, that is neural networks. Here, we are making use of multi-layered neural networks, where how human brain will work to do a task. Similarly, here in deep learning, we are doing in the same way. When you come to this let me explain the difference between artificial intelligence, machine learning, and deep learning with one example. Here, if you see here, let us assume we are having we are having one firm uh, where we are having bunch of fruits where all are mixed up. So our task is to categorize all those. So Alan is having such firm, and he is having that business where he has to segregate all these fruits based on his requirement. That is, whenever he, but here the thing is, each and every fruit is labeled with its name, and he has hired human labor where he is having domain knowledge, where he is capable of segregating all these fruits. So whenever you place so it's perfectly working well when we are having limited number of fruits and when the business is very small. But here we are getting, the business has been expanded, so the throughput of whatever segregation we're doing, it's not that much efficient. So what he wanted to do, he wanted to automate this what is that process. So what he has done, he has implemented one artificial intelligence algorithm where it is capable of segregating all this. So here what we are having the fruits, and each fruit is labeled with some code. Now this scanner will scan that code, and it is capable of segregating that fruit into different baskets. But now fruits are coming from different sources, where when it perfectly works, if all the fruits are correctly class labeled and correctly labeled and all are labeled. But what happened? Sources, fruits are coming from different sources without any class label. Without any class label, in the sense, in machine learning terminology, we are calling it as class label, without any label on the fruit. Then the scanner, then obviously will not be having any scanner, so we are unable to classify that. So what we will be doing? we are implementing one machine learning algorithm. That means next step of this year, we are taking the machine learning algorithm where it is capable of classifying the fruits into different categories without knowing the class label. How it will do. Whenever you take the apples with class labels, it learn the characteristics of the fruits, properties of the fruits. What I mean by properties means when you take the fruits, we will be having shape and color and what is that? Uh, and other properties. We can extract the properties of those fruits, right? So whenever we are having those fruits, then your machine learning algorithm is trying to understand the properties. Whenever a new fruit comes, it recollects the properties which he has learned, and it applies that, and it tries to classify the, and it tries to what is that, categorize the fruit into appropriate basket. But so here, what we are doing, we are taking the input and we are extracting the features like shape, color, that's characteristic. It can be anything. It can be anything. Characteristics of what is that fruit. And we are applying the machine learning model and we are classifying it and we are placing the fruits into appropriate basket. But when the fruits are coming from various sources, for some fruits, it is your machine learning algorithm is seeing the fruits which are not learned earlier. That means previously we haven't seen that fruit. Then means if you see a new fruit, the machine learning algorithm has learned any characteristics or properties of that fruit, then it is not capable of classifying that into a correct category. So then deep learning will come into the picture. Here we are giving different fruits. Here, if you observe, bananas are there. Here we are giving different fruits without any class label. Then here, when you provide the images of all these fruits, then this neural network, this is this is part of this. Whenever you see this deep learning, immediately you will get this neural network into the picture. This neural network will extract the features itself. Previously, in machine learning algorithm, we have extracted that as part of feature engineering, we have extracted the features. And then we have applied the model and we have classified it. When you fed the images of the fruits, then this neural network will tries to learn the patterns. It tries to learn the properties and characteristics of the object or the input which we are giving as input to this, and it automatically extract the features and then it classifies. This is how we can what is that define artificial intelligence, machine learning, and deep learning. Initially, the firm Mark has used human labor where they should have the domain knowledge as well as all should be labeled correctly. If they are labeled correctly or if they have human domain knowledge, then they can segregate. And to automate that, artificial intelligence came into the picture where it is having the scanner machine where it is capable of scanning the label of the fruit and it is capable of classifying that into appropriate category. And next, when we are not the huge number of, that is if the business is expanded and if the fruits are not labeled correctly, then it is not capable of classifying them. So what we are doing, we are extracting the features, we are learning the properties or characteristics of those of the input data. And next, if you have a new fruit, then we are going for this deep learning. So here I will be talking only about the machine learning, what steps we follow as part of this machine learning. And here, if you take this data and program as input, traditional programming, in this traditional programming, we are taking data as input. In machine learning algorithms, we are taking the data and we are developing some program. Here, what I mean by this is Whenever you give any input, it tries to learn the pattern of that, and it 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 prepares some rules, or it prepares some model, so that based on that it can classify or predict, or it can, whatever application we want, it will do accordingly. So here input data is taking the data from various resources. We are feeding the learner with various data, and here we are learning. This is very very important. Here we are learning the properties in the machine learning system, and we are generating the rules. Output is rules. Now if whenever your model is ready, your algorithm is ready, that's why here we are calling it as a program. Whenever your model is ready, then we can make use of that model in order to what is that uh, test the or apply the model on the unseen data, or test data, or validation data, or whatever it is. Oh, 1 second. Right. And next, and what is the process of this machine learning algorithm? All these are the different steps. Right. When you come to the first step, define the objectives and collect the data, prepare the data, select the appropriate algorithm. This is pre-processing, and train the model, whatever model we have trained, and apply that on the test data. And finally, we will be using that on any application. For whatever application, we can use that model for any application. Now, when you see this, the first step is collecting the data. But in real time, for first step is, sorry, defining the objectives. What I mean by defining the objectives is, here, initially, we have to understand the business problem, what actually client requires, and what inputs they are giving, and what output they are expecting. First, we have to understand that. And the next one is collecting the data. Generally, when we are doing any research or any project, we will be collecting the data, and we will be preparing what is that from the various resources, either from Kaggle or any other platform. We will be collecting information. But when you come to real time applications, client will be providing the data. We have to, that means it can be any unstructured data. So what we have to do is, we have to convert that unstructured data to structured data, and according to the client requirement, we have to perform the task. So here, when you come to the real time application, this collecting the data, in the sense, the data can be in any form. It can be structured data, unstructured data, it can be an image file or PDF document, or it can be scanned images. So whatever input we are taking, and the next step, we have to prepare the data, means we have to pre-process it. Pre-processing means we are having various steps under pre-processing. That is stopword removal. We have to remove the noise, right? And it can be converted to either in CSV format or JSON format. That is key value paste. In the dictionary format, we can convert. And the next step is, here we have to choose the algorithm. We are having various algorithms under machine learning, under classification, under regression, under clustering. We are having various algorithms. So we have to choose the appropriate algorithm where it is capable of solving our problem. And next one is, after here we can take the integrated algorithm. That is, multiple algorithms can be combined, or we can use some optimization techniques in order to what is the speed up the process, or to improve the accuracy, or whatever. We have to choose the appropriate algorithm. And next one is, we have to train that model. That means training the model, in this sense, previously we have discussed, we have taken the fruits, and we are taking the characteristics of the fruits, and we are giving them as input to your algorithm. Means here we are training our algorithm to, we are but to, what is that, to understand the pattern, or to understand the properties of that. What I mean by this is, let me show you one example here. Yes, here this is one data set. where we are having three different attributes: TV, radio, newspaper, and sales. So in this, the input is TV, radio, newspaper. These three are the attributes or features which we have given as input to your model, and this sales is the class label. So what we have to do is, whenever you give these as input to your model, it is trying to understand the relationship between these features. It is what is that, it is observing the pattern, or it is trying to understand, like that. It will be finding one equation, generalized equation. Whenever you apply this generalized equation, whenever you substitute, let us assume this is x, y, and z, some 2x plus 3y plus 3z equals to some class label. Then what happens is, here it is finding one generalized equation where when you substitute all these values, we will be getting the approximate value of this. That is not exactly the same value. It is highly impossible to get this exact value when you take the relationship between all these. So this is what is happening in training the model. So when you train the model, here whatever input we are feeding to your algorithm, it is learning, it is trying to learn the relationship between the features. For example, if you take text as an input, the text as an input means, then there we have to apply the feature engineering, and we have to prepare either CSV data or JSON data. For example, if you want to classify the document, if you are have what is that, bank has given you one set of documents where we have to segregate them, then and all the documents are containing images, tables, and text. Then as part of this preparing the data, we have to, what is that, extract the features from that. If you want to separate that, first we will be taking the heading of the what is that document from each and every page, and footer of each and every document, and next we will be reading the content. So we have divided the input document into three parts: header part, footer part, and the body part. Again, in the body, we are looking for text, images, or what is that, tables, all that information. So as part of your prepared data, pre-processing or extracting the features, what you're going to do is, you will be extracting the features and you're preparing the data. That is based on a requirement. So here, if you want to separate the documents into entire what is that, bunch of documents into different classify them into different documents, then we have to extract the features. What features we are extracting? Header, footer, and body part. So that is preparing the data. And what algorithm we have to choose. So here we can use it based on your what is the requirement, based on the type of the data which you are taking. We will be choosing the appropriate algorithm, and next we are training that model. After, once the model is built, then we will be testing on that your test data. What do you mean by this train and test data? Whatever input data we have taken, that will be divided into three: train, test, and validation. Some, let us assume 70% of the data will be used for train, and 20% is used for test, and 10% is used for validation. So on whatever 70% we have taken, after training the data, for 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 improving the accuracy, or for what is that, for hyperparameter tuning or whatever, we will be testing on the test data, and we will adjust the parameters. And this train model and select the algorithm phases will be, these two will be recursively, will be doing these two. And once the model is ready, then we will be testing our model on the validation data, right? So the we are training on the, we are training our model on the train data, and for hyperparameter tuning, and to adjust the parameters or whatever, we are applying our model on the test data, and finally we are validating our model by using the validation data. And finally, whatever model we have got, we are going to publish that on any web services or applications, whichever we are using. All these are the different phases. But one thing, uh, we need not solve every problem using only either machine learning or deep learning method. For example, if you are having the documents where we want to extract the entities, We need not go for machine learning or deep learning. If 90% accuracy is enough, we can use regular expressions, means we are trying to understand the pattern which is there in that, and we can extract that. That means nowadays everyone is trying to solve the problem using either machine learning or deep learning. Instead, we can try with some other models. If the accuracy is not good, then we can go for machine learning or deep learning models. And these are various machine learning models. At the end, I will be discussing this regression, linear regression. And here, let us see what are all the classes under machine learning model. One is supervised, unsupervised, and reinforcement learning. Supervised learning means whatever example we have discussed, that comes under supervised learning. Means we know the what is that name of the fruit. That means we know the class label of the input data. If you are having set of whatever instance we are taking, that instance is having class label, then with the known class label, if you are dealing with the data, then it is called as supervised learning. When you come to unsupervised learning, without knowing the class label, in that clustering, association analysis, association rule mining, and hidden Markov model. Under this clustering, principal component analysis, K means is the best example for clustering. When you come to supervised learning, again it is divided into two. One is classification and another one is regression. And we're having decision trees and random forest. Of course, these are different algorithms. We can say we can say all these comes under this supervised learning. And this classification and regression, when you see this classification and regression, if you are dealing with the categorical data, then we'll be going to the classification. If you are dealing with the integers, then we will be going with the regression. I'll be discussing what are all the different types of data that I encounter when you're working with the what's the CSV file or whatever input data you're taking. What are the applications of machine learning? Means speech recognition, image recognition, stock market trading, medical diagnostic, everywhere we are using this machine learning applications. Or to reduce the manual intervention in banks, we'll be using that for doc classification, or what kind of facilities the banks are providing to the customers. In order to learn all those also, we can use machine learning. And next one is what is nowadays the data scientist, that is the where sexiest job in the market. Everyone wants to become a data scientist. Even the people who are having 10 years of experience either in Java or .NET, they're learning what is that, all this machine learning and deep learning algorithms, and they wanted to become data scientist. But we have so many roles, like we might have heard so many roles like data analyst, data scientist, data engineer. So I wanted to discuss what are the roles and responsibilities of data analyst, data scientist, and data engineer. When you come to data analyst, first one, he takes data and uses to help companies to make better decisions. What do you mean by that? What he is expecting, what type of questions he answers. He wants to know what is going on now, what is there in the data, what are the causes, and what we have to do in order to improve the profit or improve the sales of so and so product. What is the trend of this particular document in the past n years or 3 years, whether our product is doing well or not. Such kind of questions will be answered by this data analyst. So what he will be doing is, he will be interpreting the insights of the data, and he will help us to take better, what is that, he help take the decision to improve our profits or to improve the sales of our products. So what are the job, what is the job of data analyst is, he'll be understanding the metrics, or he'll be understanding the business problem, and he will find out the answers, or he will get the more insights from the data. And next one is communication. Communication in the sense, the stakeholders may not have technical knowledge, so he should be capable of representing the data in the visual forms, so visualizations, and he should be capable of explaining them in easy understanding way, where the stakeholders are not having any technical knowledge. So, and finally he will be preparing the reports, that is nothing but preparing the dashboard. So what knowledge, what skill set he should have? Of course, one is SQL, structured query language, because he has to interact with the data in order to get the insights of the data. So definitely he should have the database structured query language knowledge. And next one is data visualization. Data visualization in the sense, immediately you will get some tools like Power BI, Tableau, Looker, Click. There are so many business intelligence tools. Before, of course, learning a tool is very easy, but it is more important to have or have knowledge how to visualize the data in a proper way, rather than simply using the tool. We can use tool, we can learn the tool, and simply we can, in what way we have to represent, in what way we have to visualize the data, so that the stakeholder will better understand the insights of the data. So that is data visualization. He should have that skill. And next one is domain knowledge. Domain knowledge is very, very important. Means he should have what the metric stands for, and how the metrics interact with each other, and what are the uh, what is that what are the needle movers. So these kinds of domain knowledge are necessary to ask the right questions, so that he can get the better insights, and he can contribute to the business decision. So he's not providing any solution, he's just giving the insights of the data, and he's helping us to take the decision, so he make better decision, he helps us to take better decision. So he's collecting the data, he's analyzing that, and he's creating the, in order to collect the data, he should know, he has to interact with the database, so definitely he should have SQL knowledge. And to analyze the data, to get the better insights of the data, he should be capable of visualizing that in a better way. And finally he has to represent the data. And next, when you come to data, let us first see what data scientist will do, then next how data engineer will help data scientist and data uh, analyst to interact with the database. So when you come to data scientist, here he deals with an enormous mass of structured and unstructured data with the skills math, statistics, and programming. So what data scientist will do? So data analyst is not providing any solution. He is just giving us the insights, and he is helping us to make the decisions. That's it. When you come to data scientist, he will be finding the patterns in the data and answers the questions about the futures, and that the future in the sense, that is predictions. So there are two different ways of providing the solution for that. He is providing the solution. He is providing the solution with with all this math, statistics, and programming. So he is using mainly two things. One is machine learning, and second one is deep learning. And he, as part of that, he is making use of the statistics and maths. And what are all the skills he required, and what he is representing. So he is using the data to solve the company's problems, means he is providing the solution. Like data analyst, data scientist should also have knowledge in SQL, structured query language, because he also has to interact with the database. And next is statistics and math. Generally, when you start learning machine learning, first everyone will ask you to study probabilities and statistics. That is very, very important. Statistics is very required. And because of that, when you know these statistics, you will be understanding the theories behind that machine learning algorithm. You will be understanding what is the math intuition behind that algorithm, so that you can do little modifications to the algorithm, and you can generate the efficient results. We can increase the accuracy. That is what we used to do in PhD, in research. So this is pure of academics and theoretical. That is the reason why most of the data scientist role would require a master of PhD degree. That means it's not compulsory, but they're expecting, because researchers will work on that math behind that math intuition behind the algorithms, and they know how it works. Simply, instead of using the uh, existing library, simply applying that, if you know the how it works, how that model is working, how that algorithm is working, then it will be very easy for us to generate the means we can do little modifications and we can generate the efficient results. And next one is next skill set is programming skills. Programming skill nowadays, we are using two popular programming languages, R and Python, and software development life cycle. Data scientist doesn't mean that he will only work on that. He has to test the data on different servers, and finally he has to deploy it, so that he should also have know the Git workflow and DevOps. Uh, all the basics of all these are required. Now, when come to data engineer, we have discussed about data analyst and data scientist. How these data analyst and data scientists are getting the data, and how does this data come from user behavior to the data? Then how do you make sure that the data is accountable? For that, data engineers will come into the picture. So here, if you see the definition, data engineers are the ones who develops, constructs, and tests, maintains the complete architecture of the legal scale processing system. Here, whatever data we are using, we means data analysts and data scientists are using. All those are provided by the data engineers. So the data analyst and data scientists are the data consumers who cannot perform their work without having any data engineers setup. So they build a data pipeline, uh, and they will prepare one database, so that data analyst and data data scientist can work. And next, when you yes, can you hear me? Just can you hear me, ma'am? Just I'm making sure that I'm audible. Can I? Okay, fine. So finally, what we can say is, and one more thing is, what are the skill requirement for data engineer? Like data analyst and data engineer, we here data analyst and data scientist, data engineer also needs SQL, and they should know about the cloud computing. That means Amazon, AWS, Azure, Microsoft product, and GCP, Google. These three are popular cloud services. If they should have knowledge in all this, and they should also know the parallel computing, that is Hadoop, Spark, and big data, and the software development life cycle. how it works, everything remaining all are same. So everyone should have knowledge of SDLC and SQL. Where, so when we can conclude like this, where data analyst provides what is that business decisions, means business decisions are driven by the data analyst, and simply data scientist solves the business problem, and data engineer is providing the information to data analyst and data scientists. So data engineers enable data analysts, data engineers enable data analysts and scientists to perform their work. Simple. So first data engineer will providing the information, and next data analyst will get the insights to take the decisions, and data scientist will understand that and he will provide the solution for that. So this is data analyst programming knowledge he should have. Of course, data scientist also should have some programming knowledge, R and Python. This is already I have discussed all this, and roles and responsibilities are also. So if you see data analyst, statistical analysis, reporting the data, optimize statistical efficiency and quality, data acquisition and maintenance, pattern identification, and data clean. And data scientist, mining, develop operational models, in-depth machine learning powered optimization, data enhancement, strategic planning for data analytics, data integration, blah, blah. And next data engineer. They already have discussed all this. And next, when we come to uh, types of data, and one more thing is in engineering curriculum we are having probability and statistics, but students are not interested to learn that. But before, if you want to become a data scientist, learning statistics and probability is must. Without understanding the statistics and probability concept, you can't understand the math intuition behind any machine learning algorithm. Simply googling the code and applying that sklearn or any existing libraries on the data, and what is that, finding the solution or predicting something is completely different from understanding the math intuition behind any algorithm, how it works, how it differs from other. Then only you will know. By taking, if you are having such this kind of data, then what algorithm is to be applied. If you know the math intuition behind each and every algorithm, then only you can take decision. So that subject is very, very important. And let us see what are all different types of data. We can see what is the generally we will be having numerical values. The input data may contain, for example, if you see this example which I have shown earlier, here we are having only numerical data. This is one kind numerical data, and next one is text data also we may have, and next audio data, video data. But when you prepare any CSV file, then the CSV file may contain what is that numerical data, and next one is text data, time series data, and categorical data. So numerical data which I have shown, and next categorical data I will explain with an examples, and next time series data and text data. When you see this numerical data, in numerical data we are having continuous data and discrete data. What is this continuous and what is this discrete? Continuous means, for example, salary of an employee, or height and weight of a person, and interest rates. That means the height of a person can be 5 feet 4 inches. Weight of a person can be 60 kg or 61.5 or 62.5 something. That is continuous data. And when you come to discrete data, how many students have attended this session? It can't be 20.3 or 15.3. It is either 50 or 23 or 20. That is discrete data. Or another one is how many languages you can speak. It can't be 2.5 or 3.5. It should be either 2 or 3 or 4. All those are discrete data. So continuous means that height, weight, salary of a person, the temperature or interest rates, all this comes under continuous data. And discrete means color of the, sorry, number of students have attended for this session, and how many products you have sold, how many languages you can speak. All these comes under discrete data. Next. So when you are having this numerical data, either continuous or discrete data, then you can go for regression algorithms. I will explain that. And next, when you come to categorical data, in this categorical data, here you are having three different categories: binomial, that is binary data, nominal or ordinal. Whether you are having fever or not, that is a binomial. Whether the sentiment of the text is positive or negative, binomial. Whether what is that mail is spam or not, binary data. And next, when you come to a nominal data, sorry, yeah, yeah, here we are having that, of course, not required. And when you come to nominal and ordinal, here ordinal data, first let us see this ordinal data. Ordinal data means there should be some order. Whatever class label we are taking, there should be some order. Order in the sense, for example, uh, 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 what is that? Medals, bronze, silver, and gold. We can't change the order of these three. That means the order must be, we should preserve the order of those. If he have practiced these many hours, and if he has he having this kind of diet, he has got this medal. That is the class label: silver, bronze, or gold. We can't change the order of that. That type of data comes under ordinal. When you come to nominal, uh, the color of the object, colors, if you take blue, green, red, yellow, all those are the colors. We need not preserve any order in that. We need not what is that, take them in a specific order. We can take any order of the data. That is nominal data. Here data can be either quantitative or qualitative. That is quantitative in the sense numerical information, and qualitative meaning descriptive information, that is categorization something, right? That is smells, taste, textures, attractiveness, and color. Here, yes, height, width, length, temperature, and weight of a person, all these comes under quantitative data. And this already we have discussed: continuous data and discrete data. When you see this continuous data, that is 4.7, 5.7, height of a person, all these are continuous data. uh, uh, Represents the item that can be counted, that is 0, 50, that is 50, 30, something like that. A group of 10 people, you should not have numbers like 2.5, and see 2.5 males, it's highly impossible. 4.7 females, it's impossible. All right. And here, binary data, nominal and ordinal. Binary means we will be having only two, either right or wrong, true or false, accept or reject, positive or negative, spam or not, whether he's having fever or not, something like that. That is binary. And a nominal data means type of the car, name of your school. That we need not follow any what is that order. But when you come to ordinal data, we should follow some order. This 0 to 4 means either you take 0 as lowest, or 4 as 4, we should take 4 as highest. We can't reverse this, and we can't change the order, right? um, and next one is a tour of machine learning algorithms. Here, already I have discussed this: supervised, unsupervised classification, unsupervised, and reinforcement learning. In this supervised learning, this is the main classification, categorization of this supervised learning. One is classification, and second one is regression. Under classification, You are having navy-based classification, decision trees, support vector machines, random forest, k nearest neighbor, right? And sometimes we may use combination of these algorithms. And next one is regression. If you are dealing with numerical data, then we will be going with regression. If you are dealing with categorical data, then you are going with classification. Now let us see with example. Let me explain what this regression is. And next, clustering. Without knowing any class label means you will be having instances. Just we have to read the properties of those instances, and based on algorithm we have to uh, what is that, we have to group them. We have to prepare the clusters. In this, k means is the well known algorithm under clustering. db scan, agglomerative, divisive. Yeah, another one is apart from agglomerative we are having and more algorithm, that is divisive hierarchical clustering algorithm, db scan clustering. All these are different algorithms under clustering. And reinforcement learning. Now let me discuss about this regression. When you I just wanted to take one example. One second. Here, yeah, Kaushik Katari, I'm using his blog to explain this. First, let me explain, instead of just using the machine learning libraries, SQL libraries. If you see the data in Excel, then how, whether what is the input data, and how to find the what is that features which are influencing the class label. Can we apply linear regression on that? Whether after applying that, whether our model is stable or not. How to check that? Let us see this here. This is the data: marketing budget x in thousands and actual sales. This is the budget and this is the actual sales. Now if we take the marketing budget on x axis and sales on y axis, this is the distribution of the data. That is, when marketing budget is increasing, sales are also increasing. So we can say there is some linear relationship between these two. So using stats library, what we have done, you know the slope intercept form equation, slope intercept form. I'm not explaining all those concepts in depth. Here, this is the intercept. If this equation is passing through origin, then we can write line equation as y equals to mx plus c. Y equals to mx plus c. But here it is not passing through origin. So this is the slope of the line, and this is the intercept. This is the intercept. So here, when your y equals to mx means this is the x value, x coefficient, and this is the constant. So in this equation, in this, what we have to find is, we have taken two attributes as input. One is what is that? Marketing budget and actual sales. We are having only two variables. We have to decide, we have to predict what is the sales rate if market budget is this. That is to be predicted. That for that we have to write one algorithm. So here, we have to find the relationship between y and x. And if you take the scatter plot of this, what we have identified, these two are linearly varying. If x is increasing, y is also increasing. So there is a linear relationship between these two. So the line equation is y equals to mx plus c. So here, when you see these these dots, we can't connect these dots like this. We have to find the line equation which generalizes this. We will be finding one line equation, right? There is no guarantee that this line will pass through each and every point. If it is not passing through that point, if you draw a line, means you are predicting. For example, let me show you that. Yes, here you have drawn this line for actual value of 2, x value at y value x equal to 2 is this. But here we have predicted here. This line equation is passing through this at x equals to 2. Here the value is 4. Means instead of predicting the value as 3, it has predicted as 4. Of course, there is one unit difference here. Here, what we can assume here, instead of, for example, line equation is going like this. Line is going, if the line is like this, then at x equals to 2, it is 3.2. But actual value is 3. But your algorithm has predicted it as 3.2. That is some error. There is error. So what we have to do is we have to find one line equation, generalized line equation, where the sum of all the residuals means error. Error means the difference between actual and predicted. This is the actual data. If this is the actual data, we can't connect each and every point and we can't draw one line. We are finding one line, generalized line, where the total error is minimal. In such a way, we are finding one equation. What is that line equation? Line equation is y equal to mx plus c, y equals to mx if that line equation is passing through origin. If it is not passing through origin, then y equals to mx plus c, some constant value will be there. Right? So we are trying to find that. So here in Excel, he has taken. Now, this is with that line equation using stat model with library, we found that the slope of that line is 0.0528 and intercept is 3.35. Right? Then by substituting these two values in y equals to mx plus c, x is this and y value equals to mx, that is 0.0528 into 127.4 plus 3.325, then we got this value. This is the predicted value. What is the actual one? 10.5 and 10.07. Another terminology is this y is called as dependent variable and x is independent variable, because we are computing the value of y based on x. Y is depending on x. Y equals to mx plus c. By substituting the x value in that line equation, we are computing y. So y is dependent variable and x is independent variable. So here, this is the predicted value. Now we are using math, simple math. We are computing all this. So what is the residual? That is error. What is the difference between actual and prediction? Instead of taking the actual and simply difference between actual and predicted, we have taken the residual square, error square, actual minus predicted whole square. This is the value. But here, this is the absolute quantity. So if we change the problem setting, then we have to measure all this. So what we have taken here, residual squares, sum of squares we have taken. Total sum of squares. Simply, instead of taking the difference between actuals minus predicted, we have taken residual squares, that is actual minus predicted whole square, and total sum of squares we have taken. Total sum of squares in the sense, we are taking the mean of y values and what are all the predicted difference between. This is y1 minus y bar, means this is the mean of all the y values. Then total sum of squares equals to this. And finally, we have computed r square value. R square value is, this is sum of squares is 1 minus RSS by 1 divided by TSS. So by using this, what we are going to do is, what is the distribution of these errors and how it is distributed? Is it a normal distribution? And whether the error is following any pattern or not. If it is normal distribution, yes, we can go with linear regression. If the errors are not following any pattern, in that case also we can go with linear regression. Here, if you see, we have taken, this is the data set where we have taken three inputs: TV, radio, and newspaper, and sales is the class label. Here, what is the size of the data set? Here, size of the data set is 200 instances we are having with 4 columns. One is class label. And do we have any null values? No, all are filled. We are not having any null values. If we are having null values or unfilled values, then we have to use data imputation techniques. Data imputation techniques, how we can use, how can we use data imputation techniques is based on the data type. And next, when if you see the what is that mean quartile range, 25th percentile, 75th percentile of the data, to get the distribution of the data, to understand the distribution of the data, we can take the describe. In Python code, we are having dataset dot describe. See here, advertising dot describe, then it gives this information. Of course, Python is very easy. You can Google it and you can get it. No issue in that. But here, if you take this scatter plot between what is that, each and every input variable and the output variable. Input variables are TV, radio, and newspaper. We have taken all those on x-axis and sales on y-axis. If you see the dispersion of the data, here when the value of TV is increasing, sales, there is some linear relationship between TV and sales. So what we can say, it is playing an important role. This attribute TV is playing an important role in order to decide sales. That means if you know, for example, these are the given values. Later, if I give some new value under TV, by finding the linear relationship between this TV and sales, you can substitute the TV value in this and you will get the sales value. So instead of taking these three input variables, simply I'm taking what is that, TV as input, X, and Y as output. Instead of taking, I have reduced those, I have eliminated those two, because I have identified that TV is playing one important role. I have taken that as input, and based on that, I am deciding the sales. And how to visualize this using heat map? If you see here, the correlation between TV and sales is 0.9, highly correlated. These two are highly correlated. So we have taken TV as X and sales as Y. Now, using sklearn, we have divided that into train and test. 70% of the data has been used as train data, and 30% of the data has been used as test data. You can see the train test data. Simply, this is X train, and the corresponding class labels are in Y train. This is X test, and the corresponding class labels are in Y test. And here we are adding one constant. What is that constant? Y equals to mx. We should know that C value, constant value. So using stats model API, we have added one constant value, that is 1.0 we have added, right? And using ordered least squares, we have seen ordered least squares. Simply we have computed the constant value, that is X coefficient, and the constant value we have computed. Why we have computed directly by using this stat model is, we wanted to know whether our model, can we use this, what is that regression model or not. If you see the residual dispersion, residual distribution of the data, this is following what is this normal distribution. So this is instead of applying, if you observe here, if you observe the code here, instead of, I haven't applied any linear regression library from sklearn. Simply I have used stats model API, and we have computed the quotient of X and constant value, and we have computed f stat value and distribution of the data, that is slope intercept we have identified, and with that slope intercept we have computed the predicted values. After computing the predicted values, we have computed the residual, that is nothing but error, difference between actual and predicted. And now we are seeing the what is that dispersion of that is what is the distribution of the data. And if you see, the error distribution is what is that normal distribution. So and if you see, it is this error is not following any pattern. If this error is not following any pattern, then we can use this linear regression. So initially we have taken three inputs as three variables as input, and we are having one output variable, sales. What we have done, we have seen the relation between the input variables and output variable, and TV and what is that output variable are linearly related. Using scatter plot and heat map, correlation between two variables we have seen. Then instead of taking all the three as input, here we have taken what is the TV as input, that only first column we are taking, and this is simple linear regression, only one input variable and one output. Of course, if you go to multiple linear regression, that is different story. We will be having multiple variables. We will be taking, instead of taking only TV, we will be taking other two features also, radio and newspaper. Then your equation will become beta 1 x plus beta 2, beta 1 x1 plus beta 2 x2 plus beta 3 x3 equals to y, plus some constant equals to y. But here, for understanding purpose, we have taken simple linear regression, means we are having only one input variable. Instead of taking all the three, we have taken TV, and that is x, and the corresponding y variable we have taken. So here we have seen the relation between all those, and without using any machine learning model, simply using stat model API, stats model API, we found what is that slope and intercept of y equals to mx plus c. We found m and c, and we have computed that. Then you will, by substituting the x value, you will be knowing the predicted values. We have computed the error. Then we have taken the line equation and the distribution of this error, distribution of the error. And here, if you see, it is following the normal distribution, and there it is not following any pattern. So what we can say is we can use what is that linear regression. So yes, our model is stable. So what we did, we have already divided the data. 70% of the data has been taken as a train, and 30% of the data has been taken in as a test data. So we have predicted the data. We passed the test data. How we have added constant to train data, similarly for test data also we have to add it the constant by using stats model. So the name of this test data is stats model, x underscore test underscore sm, right? And we are using the predict, and we are predicting the values. Now similarly, same as the steps which we have discussed in Excel, that is how we have done the mathematical computation. Here also we are checking the r square value. Here r square 1 minus rss by tss, story behind that. Okay, now r square value we have computed, it is 0.79. So if the value is closer to 1, if the value is closer to 1, because what is the formula, 1 minus something we are taking, if that error is minimal, then always the value will be closer to 1. So what we can say, yes, our model will work well on either test or validation or unseen data if it is closer to 1. Simple equation is 1 minus tss by rs by ts. You 1 minus something we are reducing, that is the error. So if minimal me you are reducing, me you are not, we are having minimal error. So always the value will be closer to 1. So if it is closer to 1, means your model is stable and it works well on unseen data. That's right. So see how we have computed slope and intercept using stats model. Here if you see, using in sklearn we have taken, now we are using linear regression which is in sklearn Python library. In sklearn linear model we are having linear regression. Now we are applying that, and we are computing the slope and intercept. This is 6.948 and 0.05. Using stats model, what are the values of that 6.948 and 0.0054. Here using Python library we have computed 0.054, both are same. And we are what is that computing the r score for train as well as test. For train data it is 0.81, for test data 0.78. There is no much difference, so simply we can say our model is not overfitting. So here in two ways we have, there is no confusion here. Why I am explaining this is, we have directly by taking the data, simply we haven't applied this linear regression which is there in sklearn. First we try to understand the relationship between input and output variable, that is what is that TV, radio, and the other variable. And instead of taking, this is a simple linear regression. So out of these three input variables, TV is having linear relationship with the output variable, that is sales. So we have taken that x as input, and that sales as output variable, dependent variable. X is the independent variable. So, and in that, using stats model API, we have computed directly slope intercept. Slope intercept. With that, we have computed the error, and we have taken the what is that distribution of the error, and we also have verified whether it is following any pattern. If it is following any pattern, then we should not use it. Is not following any pattern. This is like scatter plot. There is no relation, so it is not following any pattern, so we can use. So what we did, and with the same in slope and intercept, we have computed the squared value, r squared value. It is 0.79. Till now, till this point, we haven't used any sklearn Python library, right? Using only stats model, we have applied that. That's mean assume that mathematically we have done that. Now we whenever what is that we use linear regression. Again, we have taken the data, we have divided that into 70 and 30, and always of course, if there are multiple classes, always use the stratified sampling. Here numerical data, of course, what is that regression. So simply we have divided that into 70 and 30 percentage. 70% train and test set is having 30% of the instances. All right. And using sklearn, now we are using Python linear regression, and we have computed the slope. The values which we have got, C and slope values, that is constant and intercept values, slope and intercept values, those are same as the values which we have got using stats models. And 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 we are also computing with these two values, we are also computing the r squared value for train and test. Even using stat models also, we have got the same value. And for train data, it is 0.81, for test data 0.79. That means these values must be closer to 1, as I discussed. So, and there is no much difference between these two. So, there is no overfitting. Our model is working well. This is linear regression. Similarly, so uh, before before applying any algorithm on any data set, first we have to understand what kind of inputs we are having. But generally, in Kaggle competitions or whatever, data is directly available. Ready-made data is available, and you will be pre-processing it either if there is any noise, or if what is that, if data is not filled, data imputation techniques. If it is text, then removing the stop words and applying the stemming, lemmatization, and using some word embedding technique, because characters won't be understandable by machine learning algorithms, so we have to convert the text into numericals. Then we are having different machine learning algorithms, TF-IDF, bag of words, word to vec, document to vec, BERT. Nowadays everyone is talking about BERT technique. We are having so many, but in real time scenarios, you will not be having such columns. Like data will not be in CSV format. You will be having some unstructured data. First, you have to understand that what is the business requirement, what client is expecting. Then how this input data is to be consider, how that is to be converted to structured data. And next, for to fulfill the client requirement, what features are to be extracted. That is very feature engineering. That feature engineering is very interesting concept, feature engineering. But when you work with deep learning, of course, it tries to understand the pattern, and it itself evaluates the features. That is different story. But if you are using machine learning model, if you take any unstructured data, after converting that into structure, it can be either CSV or JSON. What features are to be extracted from that? That is very, very important. After preparing the data, then we can apply any machine learning algorithm based on your features and based on the requirement of the business. Uh, Uh, that's it. Any questions, man? Guys, I don't know who are the.
Thank you, ma'am. Anyone, any questions, please? Ma'am, there are no questions. Thank
Okay.
you for giving basic idea and the differences between AI, ML, and deep learning, and making us understand about data analyst and scientist and data engineer how they handle the database, and finally telling about the clear problem and how to handle the linear regression and finding the mean square error for training and testing of the data. Thank you, ma'am. Thank you very much.
Thank you, ma'am. Thanks for providing this opportunity. Actually, I did my MTech in VNR VJIT, but while reading ma'am said from JNTU, it's VNR VJIT. I worked in VNR VJIT also. Um, I'm very proud that I'm the student of VNR VJIT, ma'am. Thank you very much for providing this opportunity. Thank you so much, ma'am. And finally, I thank my daughter in helping me to prepare this PPT. Thank you, ma'am.
That's great, ma'am. Thank you, ma'am.
Thank you so much, ma'am. Bye bye. Thank you all.